Okay, so the next model, we are actually dealing with a radioactive substance. As I shared with you guys in an earlier video, usually that's exponential decay. And it's modeled by A of t equals 500, 2.35 raised to the negative 0.025 t. T in this case is measured in seconds, and AMT is the amount of our substance measured in grams. So again, stripping away some stuff, let's forget about the 500 for a moment. We're looking at 2.35. So again, my A is greater than 1, right? And since T is an unknown and it's negative, right, this is like looking at negative X. So we are looking basically at a decay model, right? So there's your answer for the first one. So technically speaking, this is decay model for all practical purposes. What is the initial amount of the substance? So how much substance did I have when time equals 0 according to this model? So using our function, we're going to look for A of 0. This is 500, 2.35 to the negative 0.025 times 0. Well, anything times 0 is 0. Anything to the 0 power is 1. And so we get 500. So there were 500 grams, all right, when this model started or when this substance was made. So there's your initial amount. How much of the substance remains after 5 seconds? Unlike the last example, we are measured in seconds here. So we are looking at A of 5. And so plugging things into the function, it's going to look like this, right, times 5, right? If you want to maybe parentheses around that, right? And so again, I apologize. I don't have a calculator that I can bring into this application that I'm doing. All I can tell you is that I am using the TI 84, and my input line will look like this, right? It's going to be 500. I'm going to open up a set of parentheses, put 2.35 in there, open up the caret feature, and then in another set of parentheses, write 0.025 times 5, close parentheses. So when I do all that, let me go ahead and do that number crunching into my calculator, right? So 500, open up a set of parentheses, 2.35, close the parentheses, raise that, open up another set of parentheses, negative 0.025, right, times 5. All right, and when I do that, my calculator's giving me 449.35. So that's how many grams we have going after 5 seconds. So you can see we've already lost, within the first 5 seconds, we've already lost 51 grams almost. So it's decaying pretty fast. But as we saw, right, what happens is it starts decaying fast, but as time moves forward, right, it's slowly going to go to 0. So we're never really going to get rid of the substance in its entirety. According to the model, there will always be a little bit there. All right, so that wraps up all our videos, all our lessons, all our content for our Math 121 class. Congratulations, you guys made it through. All right, let's finish strong, get this homework done, get some reviewing and redoing of your notes, and let's get ready for tests and some finals and get out of here. All right, thank you for your time. Thank you for your effort. Thank you for listening to me all semester. I hope you've all learned well, and I've enjoyed teaching you guys. See you in class.